All right, chemistry guys. So I think I figured this out now so that while I'm going over this stuff, you can actually see my crazy mug up here. I don't know if you like that or not, but that's the way I have it set up. So, well, anyway, want to go over physical and chemical changes with you guys. But before we do that, just a couple quick things. Make sure that you're going over the other stuff that we've looked at this chapter as well. So we've gone over Objective 1, the purpose of chemistry. Objective 2, the differences between atoms, elements, and compounds. Intensive and extensive properties, and the practice here. And then we get to the physical and chemical properties. Now, we already did this work here on Wednesday, so I'm not going to go over this again. What I do want to focus on is the physical and chemical changes. So we did this lab, and when you did this lab, you should have seen or should have observed three very important things. And those three really important things are these. Let's get a text box here. It is that we had a color change. We had production of a gas. And we had temperature change. Those are the three things that, three different observations that we should have made in order to tell that a chemical change was occurring. Color change, production of a gas, and temperature change. Those are three of the four things that we look to for evidence of a chemical change. And when we get into number 3 here, it says look up and find out what chemists use for evidence of a chemical change. List them here. Well, it's these three: color change, production of a gas, and temperature change. Also here with the temperature change, we also have produces light. And that happens when we have combustion reactions. So these two go together. Right here. They are not separate. So the last one, though, that is different is the formation of a precipitate. And remember that when we put this on the board, this is when we have two aqueous solutions that produce a solid. Sorry, it's getting kind of messy in here. Still learning how this whole thing works. But right here, box this one in. That's the last one. And this is a really important one. We can get false positives from the other ones. And a false positive is when you get evidence to show that it's a chemical change when really it's not. For example, a color change would be food coloring in water. That is a false positive. Production of a gas, if we have liquid changing into steam, so we have that phase change, that is also a false positive. But this one will never be a false positive. This always is true, and that is what is called a formation of a precipitate. So the four things that you need to know are the ones that I'm going to put X's next to: color change, production of a gas, temperature change, formation of a precipitate. Again, these are the observations that we use as evidence of a chemical change. All right, let's wipe this and scroll down. All right, so here are those false positives that I talked about. So we have a false positive with a color change. All right, so that was the afternoon bell, so you're probably going to get some noise from the outside, but we'll just work through it. So we have a color change, we have a false positive for the production of a gas. And the two that we're going to look at here, the two big ones, we have food coloring and water. And then down here we have, we're just going to say phase changes. So liquid changes to a gas. And so the big one here is that water vapor. So if we have liquid water, it changes to gaseous water. It's still water. It hasn't changed chemical composition. It's just now in a gas form. And then the food cleaner water, also we could do any kind of things like writing on a chalkboard or writing on a whiteboard. Any of those things have to do with a physical change. It's a false positive. That color change does not indicate that a chemical change is occurring. All right. Wipe this guy. What can we do to determine if we have a false positive, or to limit how much a false positive there is? And that is dependent on the data. More observations that point towards a chemical change. Can I move this? No, not really. More observations that point towards a chemical change is going to indicate that we have a true chemical change and not a false positive. So if you have a color change and a production of a gas, that's going to be a chemical change. It won't be a physical change. If you have both of those things there, it's very unlikely that both of those are going to be false positives. All right, number 5. I'm not going to type anything here. So besides the stuff that we learn in lab, other things you're going to learn are things like where your lab station is, where to get goggles, how to clean goggles, who your lab partners are, how to get instructions, where to look for instructions in the lab notebook. Those are the things we're after here. So this is the first lab you did, and those types of procedural stuff you're learning how to do in lab. All right. Now we have the physical properties, and then chemical changes and how they are different. All right, so physical property. This is a property that can be observed without changing the chemical composition. And so the examples that we're getting in class here were not really what we were after until I sort of coached people through this. So this is things like the color, texture, boiling point, boiling point and melting point. Density. All of these things are examples of properties that you can observe without changing the chemical composition, and that's the main difference here. How we relate them. Chemical changes change the composition. Physical changes don't. So that's what we can think of when we're trying to determine if it's a chemical change or a physical change. Think, does it change the chemical composition? If the answer is yes, it's chemical. If the answer is no, it's physical. Then we go back to those evidence pieces to support that idea. Was there color change? Was there production of a gas? Was there formation of a precipitate? Was there a temperature change? Was light produced? All of those things. All right, so down here, the 3 states of matter. We have solid, we have liquid, we have gas. Those are the 3. The last one, plasma, is one that we don't work with in chemistry, so we don't have to worry about that one. All right, wiping this. Let's scroll down to the next page. We've hit this several times, but let's just make sure. We have the phase changes. So this is going to be like liquid water changing to a vapor. And this is always, ladies and gentlemen, a physical change. Make sure that you have that. It's always physical. This is still water, no matter what. We could do this with other substances as well. The example that we see later on is gasoline. Gasoline evaporated is still gasoline. It hasn't changed chemical composition. So anytime we have evaporation, it's going to be a physical change. Anytime we have something that freezes, so it changes into a solid, that's going to be a physical change. It does not matter. All right, gas and vapor. So gases are gases at room temperature. At room temp. All right, and then vapors are liquids at room temp. So what's the difference here? What's the problem? And really what it is that this is a gaseous form. So we have that gas of something that is normally a liquid. And so we talk about water vapor. And water is normally that liquid at room temperature, but when it's a gas, we call it water vapor. So we don't call it water gas. That's where it is. How are chemical reactions expressed? We have reactants that we start with, and then we end up with products on the other side. So reactants are on the left, products are on the right. And then we have a simple one that we can look at is the production of rust. Iron is the chemical that we're starting with, that's the metal. We can react it with oxygen, and that produces iron oxide. Now, you'll notice that we start with one iron here, and we have two irons there. Don't worry about that now. We'll talk about that when we get in another chapter. But we see here that we have the reactants on the right, and we have the products on the left. So let's go ahead and write that out here. Again, reactants and products. For the test, you'll have to be able to identify those types of things. You don't have to come up with your own chemical reaction. All right, let's wipe this. Physical and chemical changes. Let's go through these quickly and identify them. If you haven't already done this, you should. So pause the video now and answer these questions on your own, because if all you're going to do is copy my work down, it's not going to be helpful. All right, so quickly, I'm going to give the answers and we'll go back and talk about them. Physical, chemical, both, physical, chemical, physical, physical. That kind of just alternates, doesn't it? All right. If we have a chemical change, we want to talk about the criteria. So if we look at the acid that causes limestone to fizz, that fizzing is a gas. So we say produces a gas. The raw shrimp, it changes color. There you go. It changes color from white gray to the red. So that's the indication here. Now that's kind of a difficult one because that change in color can be that false positive. But let's just say this. Anytime we see something that's cooked, it's going to be it's going to be a chemical change. Now there's some exceptions to that, obviously, like when you boil water, that's a physical change. You're just boiling water. Or if you cook pasta, all you're doing is adding water to the pasta. But if you are looking here and you see a color change of like a meat, so you're cooking meat, it's always going to be a physical change. Chewing food is both. I'm not going to talk about the criteria because it gets a little weird in here, but it's both because it breaks down when we chew it. We just break it down into pieces. It's also chemical because of the enzymes in your mouth, in your saliva, that starts the digestive process. So you have that. Nail rusting, color change. And what you don't see here, guys, is if you have uh, a rusting process that occurs quickly enough, there is a temperature change here. But what we see, what we can observe is that color change. Natural gas burning to heat your home, we have the temperature change. We also have the color change. And we have the production of the gas. We have everything there. All right. So those are the answers to those. And for sure on the test, you're going to see problems like this. So if you don't understand these, make sure you send emails or talk to friends and get that figured out. All right. This gets wiped. And then the last part. We have the qualitative and quantitative data. In this lab, we gathered information that was qualitative. Because we didn't gather any numbers. Qualitative is the quality of it. So, and then that is your observations. Where the quantitative those are going to be numbers. So anytime that you look at data that you're collecting, if you have observations, that's qualitative. If you have numbers, that's going to be quantitative. And then what changes could you have made in order to make this quantitative? So the big one here is that you could have collected temperature. Use thermometer. Oops. Thermometer. Thermometer. The other thing is that you could have measured the liquids. Those are the two ways that you could have made this quantitative. All right, well, there you have it. That is the last stuff for this chapter involving physical and chemical changes. And this is kind of a big deal for this chapter, so make sure that you take some time and study this stuff.